on YouTube afterwards.
This meeting is being recorded.
Great. My name is Stephen. On Zindi, I go by the name Kolesh JR or Kolesh Jr. I'm from Nairobi, Kenya. I finished school like 1 month ago. Currently, I'm on my internship at a company called Zindi Labs. And I'm so glad to be having you all here. So, Koding Kolesh is it's a session where I decided since weekends I don't do a lot of things. Instead of me getting bored, I come engage with the Zindi community in a fun like coding session where both beginners and intermediates can learn. And as Amy said before, as much as I am in the top 1% of the Zindi participants, I don't know everything. I'm also on a learning journey, and I'm so grateful to Zindi because all my machine learning knowledge I've learned through competitions, and it's so much fun learning through competitions, and that's what I'm aiming to help other guys who are starting out or who are intermediates doing solving their first or it cannot be it may not be the first challenge, but yeah, just having fun coding. So our first session today will be going. Let me share my screen.
Hey Kolesh, we've got a message from Kefa saying that there's a bit of feedback in your mic. Is your shirt maybe rubbing against your computer? Maybe you can...
Oh, okay. Amy, can you hear me clearly?
Bit noisy, but I think it's fine. I think just pronounce things clearly and you'll be good.
Oh,
If you
okay.
can't hear Kolesh nicely, just ask him to repeat something, put it in the chat. Yeah, you can start sharing your screen.
Anyone else who is experiencing the same problem as Kefa? Okay, so yeah, I tried using headphones before, and Amy said she can't hear me, so maybe I'll try.
It's somehow sounding better now, but yeah, try your headphones. And now we can't hear you at all. I can't hear you. I can't hear you.
Yeah, me too. I can't hear him.
Yeah, so see, I can't use my headphones. That's why I really don't know why. So I just have to.
I think I
It's
can hear you
fine.
nicely. Yeah.
Oh, okay, cool.
I think it's better now.
Now I'm going to share my screen. And I'm going to disable the my video feed. So cool. So can everyone see the Zindi competition RMB Monthly Mini Challenge Nowcast April?
Yeah, I can see it.
Cool. So our first competition to solve will be how to nowcast South Africa's April CPI. This challenge started way back in April. Now we are in mini challenge 4, I guess. April, May, June, July. We are in nowcast in July, and I saw it best to start from the beginning so that anyone who has not like competed in the before ones can have a base of how this competition goes, etc, etc. So the objective is Nowcasting South Africa's April CPI. Yeah, the data, we have been provided a lot of data.
Is it just me or did it freeze? Because the screen is.
Yeah, I thought it was on my side as well. Now I think it's Kolesh's side.
Let me ping him.
I think it's back. I think it's back.
Which is super fun, and I'll tell you from the beginning that's for you guys. So we are, and you can go to GitHub. Can you hear me?
Kolesh, just 1 second. Could you start again with the RMB Mini challenge? You dipped out for a minute.
Oh, okay.
So you're just telling us about the data.
Oh, we were at the data. So
Yeah.
I was telling you guys that we have been provided a lot of data here, but the most important one is the CPI historic values. But we have additional data like currency, indices, vehicle sales, and then we have these links where you can go add additional data as long as it's freely available. So all our experiments are going to do them on Google Colab. So you go search Google Colab on Google, then click on the first, welcome to Colab. Yeah, I bet everyone has used Google Colab, and click new notebook. Cool. Rename. Nice. So I've shared the link to this GitHub repo. All our projects I'll be posting them here, and this is to help us like have a common base of where we'll be learning from. So you can click clone, whichever way you prefer. Then git clone the repo. So are guys following? Hello, are you guys following?
Yes, yes.
Oh, cool, Julius. So I hope everyone has, so when you git clone, I hope everyone has found that repo. When you git clone, it will come to the content. Now you have the challenge folder, which has RMB, Nowcasting April, and it has the CPI historic values of April and NAMSA vehicle sales, because those are the two files we'll be interacting with the most in this session. Then, okay, this details I'll tell you its work. Then here, so I wanted to like add all reusable code, so that's you don't like reverse engineer anything that's already there. So when you go to this EDA folder, you'll have EDA Pi. It has a lot of useful code for exploratory data analysis. You should check it out. But you're not going to use it today because you're not going to do a lot of EDA since this data is really small. Cool. So nice. Next, you're going to import libraries we are going to use. The normal ones. Okay, you can just copy and paste this from your past projects, but since it's a live coding session, let's do it from scratch. Then in future sessions, we'll just be copy and pasting. So pandas is for data manipulation, data frame manipulation, NumPy operations. Seaborn is for visualization together with matplotlib. Then you're gonna need math for something. You'll see. Then you're going to import. Okay. So when a competition launches on Zindi, you should come look at the objective evaluation. So the evaluation is root mean squared error, and yeah, so that indicates that you are dealing with a regression problem. So we're going to import the mean squared error from sklearn, and our model which we are going to use today is linear regression, but you can try. Okay, we'll see why linear regression. We'll see why, and why not boosting algorithms like random forest or the other GBDT models. So and metrics. Then we are going to, since linear regression is really affected by, but all these values are kind of on the same scale, but we are going to need a standard scalar or min-max scalar, whichever works better. Cool. Also, to clean up our code, we need to ignore the warnings. So nice. I think we have every library we need. So yeah, can run that. The next part is data loading. The best practice is to always set up a path. Then all your data, you load them using that path. Now, when you shift these projects to another, okay, let's say VS Code, you'll just change the path to where your working folder is. So currently our path is, if you have cloned the repo, you'll see here challenges, then RMB, Nowcast in April, and you can see the files. So copy path, how I like to do this is add okay, let's see. Chain is equals to, it's actually not chain, so CPI is equals to PD dot read CSV. Then you start with the path, then you concat the name of your data. In our case, that's this. So that's CSV. Cool. We are not going to use NumSA right now, so let that stay there. Then, so when you successfully load the data, you can look at the first 5 rows using CPI. I mean the f.head. The f here is our CPI. This var we have used. So you can just, since this okay, CPI.shape is to check how many columns and rows we have. We have 195 rows. So, and okay, I'll show you a cool way to do all this. Display then. That's like a description of the data of what you want to display. So CPI.head, you can make it too specific, like CPI data 5 first rows, then CPI shape. Cool. Now you have the description, you have CPI.head, you can view the first 5 rows, then you can check out the shape, the number of rows and columns. So when you look at this data, you can see that it is in a long format. In short, this category, you want them to be columns. So currently it's in a long format, but now we have to convert them into a wide format. And how we do this is pivoting the data. Set. And this competition is actually really fun because you learn a lot about data frame manipulation. So you learn about pivoting, you learn about melting the data frames, and we are going to see all of this. So how we pivot is now data frame, which is CPI. Then this is a method called pivots. The index, you want it to be the month. This here, the month is the index. Then columns. You want these categories here to be the columns. So instead of having like multiple rows of the same dates, you have one date now in a wide format, and you're going to see that in a minute. So columns category, then values. This so you can either choose percentage change or the normal value, but you're going to go with this value. So in this experiment, you're not going to use percentage change at all, but you can in your further experiments. So like this is just a gateway to show you how you can solve this problem. And everyone has his or her own preference. So if you think percentage change will add an improvement to your model, use it. So you reset the index. Cool. Now we look at the pivoted data frame, now you can see that we have the columns as the categories, and now we have one row per date. Okay, it's not sorted yet, but you can do that. So SPI pivots, the month, is equals to, so we have to change it into a date time data type. So pd dot to date time. Then we sort the data frame. Cool. And now when you look at it, now we have a sorted data frame. So yeah, 22, and the data spans from January last year to March. Okay, March, because this we are now casting April. And now you don't have the values for April because that is what you're trying to predict. That is what you're trying to forecast. So any question up to now? Does anyone have a question? Oh, actually, XGBoost is all you need. Okay, XGBoost is all you need for some type of. Okay, that is arguable. That is arguable. And XGBoost for this problem, like we're always told to use the simplest method possible. The simplest method possible. So XGBoost is. Can you explain again your reasoning for pivoting? Cool. And why drop is equals to true? Nice. I'll answer this. So I'll remove this.
Can I ask a question?
So that you can. First, I'll explain why we pivot. So we have data in these long formats, right? And when you look at the submission file, it's also in the long format, but this is after melting. Now you have an ID, then columns. While trying to model using this long format, it's really impossible because we are aiming to use, since we are using an ML okay, I'm going to use an ML approach. We need to feature engineer our data set, and to feature engineer our data sets, we need to do it for each category. See, if these are multiple categories: headline CPI, food and non-alcoholic beverages, etc. But in normal cases, we always have like a target column, and this target column is like, take for example, a target column as only headline CPI. So headline CPI, we have values for January, Feb, March, April, and we have, which is different from food and non-alcoholic beverages. So you have to separate the logic between different categories because we are trying to predict for each category its value. That's the idea of widening the data frame, so that now you have logic for each column. And why drop is equals to true. Cool. So let's repeat all this. And we see. Now you can see that you have this. It's not ordered index because now we have sorted. Now when you use resets index without drop is equals to true, we'll have this. We'll now have two indexes. Like we have this index and we have this category index. Now when you set this to drop is equals to true, we'll drop 1. Cool. Now we have dropped the index. That's was there before. That's why we are using drop is equals to 2 to drop the resulting index after sorting. Nice. Any other question? I hope I've answered your questions. Drop is equals to 2 and reasoning for pivoting, right?
Yes,
Hello.
thank you.
Hello.
Hello.
Hello. Can you hear me?
Yeah, I can hear you.
Oh, my question was,
Yeah.
from all the data we were given, how did
Yeah.
you come up about choosing the CPI historic data being your data set?
Oh, how did I choose?
Yeah, because mine I used many like data frames, so I ended up
Yeah.
yeah.
So why I chose, okay, you can choose any other data sets, but the reason for choosing CPI is because that is what you are trying to predict. We are trying to predict CPI, which is the target column. Now, in an ML approach, which we are jumping too far, but we have something we call lagging. So if you want to use an ML approach to this competition, you have to do lagging. Where lagging is, you have to find values from previous months to see if they affect the current value for this month. And you're going to see all that logic when we continue with the rest of the code. Cool. At the end of the session, I'll ask, you'll get a better understanding why we chose CPI, I mean, the historical values. But we are going to use also the vehicle sales, and if time allows, we are going to use some of the additional links you've been given. Cool? Was it careful?
Yeah, thank you for that.
Oh, cool. You're going to get a better understanding when we continue. So let's continue with the next session. You can just post your question on the comments. I'll be checking it frequently. Cool. Now, the next part. So what we are trying to do is now casting for April, but you can see the end date here is March. Now we have to add a row for April, but with non-values because we don't know the values. That is what we are trying to predict. So you can do this in many ways, but I'll show you the basic way to do this. So, and which is flexible, so that when you're given other nowcasting challenges, you're going to just change the dates only, as long as you have the correct CPI historic value data sets. So we are trying to predict for April. Now this is what you're going to change in this code only. So for the other nowcasting challenges. So what we are doing, we are just adding a row which has 230430, which represents April, but with non-values. So all you need is this month. Then all these values will this month, this here. Then all these values will be zeros or nuns. Yeah. So you create a date string, make it an object, create a new row, then append. But in the newer versions of pandas, like they have removed the append method. So now we have to concat. Now That's why you have created a new data frame so that you can concat it. Cool. Yeah, now you have a new row 2023-0430 with nuns. Nice. So the next thing we are going to do is, okay. As I said, there's so many approaches. There's a lot of approaches to deal with this problem. Okay, if you are aiming to use the simplest method possible, so when you come here, we have this utils.py and created a, so you can come here and copy paste this code. It's an EDA code, so I saw it best to like create it before because it's just to visualize the plots. Cool. Now we are going to place it before we add the row. This is to show you the simplest way of dealing with this problem. Now we are going to what's happening here. We are creating seasonality trends between different years. Now you can see we have all the categories, beverages and tobacco, clothing and footwear. The most unique thing is, see, in education, it's like it's following last year's trends completely. If you see education is following last year's trend, so an assumption is that even this year, education
Hello, Kolesh. We can't hear you.
So the only thing that is changing for this year hello, sorry guys, I lost my internet connection. Can you hear me now?
Yeah.
Yes, yes.
Can you guys see my screen?
No.
Not yet.
Cool. Nice. Where did I get lost? I was explaining the seasonality trends.
Yes, I think you can restart from the seasonality.
Oh, so you had already seen this, I mean, these graphs, these charts.
Yeah, you were saying education is probably going to look similar to last year. And then we lost you.
Here, I bet. Cool. I'll just explain it from scratch. So I showed you guys where you can find this code. It's in the utils for RMB challenge, right? So what I was trying to explain is there's some categories which like they don't change. The change that happened last year is the same change that is happening this year. For example, education, alcoholic beverages and tobacco, health too, but it's not. Don't assume like it's going to follow that like completely new. So what I was trying to explain is the simplest way is to go find the difference of change between months between last year. For example, the change that happened April minus March last year for each category, then try to add that difference to the value of March this year and submit that as a prediction or as a forecasted value. And you'll be surprised at how that simple approach performs on the leaderboard. It's actually top 20 solutions for April. But it's not assumed. It's just as an assumption. And this approach is not very flexible because you can see communication isn't changing as last year. There's some other clothing and footwear. It's not changing as last year. So you can just try to experiment on the categories which follow last year's trend. And yeah, so that's an idea, a basic idea, but that's not what I'm going to show you today. Today I'm going to show you an ML approach. So that is what I just wanted to show you guys. Now let's continue with our previous approach. Now we have values for April filled with nuns. Now what we want to add as features is the value that happened in the previous month. So for example, we want to add previous month's value for each of these columns for alcoholic beverages and tobacco, clothing and footwear, communication, etc., etc., etc. And that's where lagging comes in. And lagging is you try to find the change that happened in the previous months, and you see if there's patterns to this current value. So it's very simple to do that in pandas. You just shift. So if you want to find so you have to know how many months you want the change. So the best explanation for lagging is you look at past values of a variable. So for example, headline CPI, for example, to understand its patterns or make predictions. By creating lag features, you can include information from previous time points in your analysis. This can help you find trends, detect patterns, or forecast what might happen in the future based on what happened in the past. So based on what happened in the past month, based on what happened in the past 2 months, 3 months, 4 months. So you just have to find your sweet spot, how many months you want to create lags for. So features, create a list of features you want to lag, which is CPI pivots, dot columns. You just ignore this month. So you start from 1. Yeah. And convert this to lists. Cool. Nice. Now you have the features you want to lag. You want to lag alcoholic beverages and tobacco, all those target columns. And now how you do this is for calling feeds to lag. Then you specify how many time points previously you want to find their value. So for I in range, starting from 1, because you cannot lag at 0, 0 is the current value. Let's say 1 month, so that will lag only for 1 month. You can use range or you can use for I in, then pass a list of how many months you want. So based on your preference. So take the call, then you, not the call itself, because you want to add additional columns. So what you're going to do is use an F string, then name it previous, then call, or no, you want to previous 2 months headline CPI. So the I, which is the how many months you want, month, add month, then the column value which you want, then PD dots is CPI pivots, the data frame itself, the column, then you shift using the I. Nice. And we are going to see what this does. So what this does is it goes to this categorical column, creates a previous month value, and appends it to the end of the data frame. Nice. Now, why we are doing this is because since we are trying to predict for April and we don't have features to use, we are trying to create features for April. Now, April, when you look at this data frame up here, you can see that we had nuns. We had nuns everywhere. But now, in this new one, after creating lags, you can see that it has values like previous 1 month education, previous 1 month food and non-alcoholic beverages, previous 1 month headline CPI, which have values. The first row doesn't have values because we don't have dates to infer from. So we need to drop this first row. So that you can do in many ways too, but okay. We drop the index 0, which is the first one, because now these are the features, independent features we'll use. Then these are the these are the dependent features, like the target columns, and now this will be our independent features, the features to train our model with. And now, since linear regression, ridge, they don't have mechanic, they don't deal with nonce. We have to fill the nonce for linear regression. It's not like a cat boost or like GBM. So you can fill them either way. So you can fill them with zeros, or a better way is to use a timely way to fill the nonce. So we can do this with bfill. So bfill, what that it does, it takes, for example, if for example we had retained this index 1 row, bfill will take 100.0 this value here and fill it to that non value. That's what bfill is. But I tried with other approaches, so like filling with zeros, filling with means or medians, but they don't work well. But for you, maybe they can work well. So it's a matter of experimentation. So cool. And that's basically what you need. Only that for Okay, not only that, but to create your first baseline, that is what you need. Next, we are going to create. Next, we are going to, okay, questions. Hello, guys, do you have questions? No screen? You can't see, all the time you're not seeing my screen?
Nah, I can see your screen. I can see your screen.
Oh, you can see my screen, oh, cool. So, any questions up to where we are?
For me personally, no. It's all right. Not sure about everybody else.
Oh, Kefar was the guy who was asking why I chose CPI historic values as my main data. Kefar, do you understand now why? It's because I used that historic values to create independent features based on previous month values. Oh, cool. You understand now. Amazing. Anyone else with a question? If not, any other question? Let's continue. What we are going to do now is creating our training and validation sets, because now we have to like see how well our model is performing, and when we add new features, how well those features affect the score. So training and validation sets and test sets. So train will have all the data except this April month's values, because that is what you're trying to predict. So how we can do this is train is equals to train, then you can use is in, or we don't have train. So this is not supposed to be train. This is supposed to be CPI pivot. Same to this. Now the month. So train will not have 2023-04 that. But test will have that. So test is equals to that. And now we have to, other than the tests, what we are trying to predict on. Sorry, guys.
Hello?
Hello. Sorry, guys.
Yeah,
Our network is so unstable. Where are we? Here?
Yes.
Cool. We're just trying to create training and validation sets. So April for tests, March for validation. Yeah. Now you can. Nice. So trainers 14 rows, test 1. Training set has 13, validation set has 1. So that shows we have done the right thing. Now to the fun parts now. To the modeling parts. Cool. So here what we are trying to do is we are trying to predict for each categorical column, right? So we have to submit for alcoholic beverages and tobacco, for clothing and footwear, for communication, for education, all those target columns. So that means you have to train for each target column, you have to train for me, I'm using linear regression. You have to train a linear regression for each. So that I bet that was the hard part for most of the guys. So in normal cases, we'll have targets call to be, let's say, targets, right? So, but in this case, our target calls is all this. The features we lagged. What did we name? Fits to lag. Yeah. So all these are target column. This is a target, this is a target, these are targets, all this. So we have to create a linear regression model for each target, then create the overall RMSE. So how we'll do this is, now we have our target columns, which is fits to lag, or we can just rename this to target columns is equals to that. Anyways, now our features is the lagged features we created. So this is what we'll train our model with, then try to predict the target columns. And our features is everything that is not in the features to lag. So call for call in train.columns, if call not in target columns, plus this month. So those are our features. And then, yeah, now we are going to use these lagged features as inputs to our models, trying to predict the target columns. Now you have features, now you have target columns. Now for each target column, we have to train a linear regression. Nice. So our X-train is, since this, okay, we are going to do this in 2 steps. First, we are going to do training and validation. We are going to change that later. And now we also have training and inference. These are 2 separate things. So training and validation is to see how your model performs locally. Training and inference is to train and predict for submission on the Zindi platform. So our X-train, we are going to use training sets with the features. And then Y-train is all those target columns. Then xvalid, you use the validation set we created. Now we have our X-train, we have our Y-train, X-valid, Y-valid. Then, since you're training, okay, I hope is everyone following? I hope I have not lost anyone.
We're all here. We're all here.
Okay, cool. No questions? Okay, let's continue with the modeling. We have to create a dictionary to store all our fitted LR models for each specific target columns. Okay, this is not too hard. So, take for example, this was the only target. Okay, headline CPI was the only target column we were trying to predict. We'll have only headline CPI as our target. So we'll train our linear regression model, fit it on features trained to predict headline CPI, and then use that for prediction. But now we have like 11 targets. So for each target, you have to create a linear regression model for each target to predict each target. And okay, maybe it's going to make sense when you do it. So you create a dictionary to store all your LR linear regression models, YPRED, an empty list to store your predictions, scalar. You can choose either between min-max scalar or standard scalar, or your preferable scalars. There are a lot of scalars. Then we're going to train training. Now, for each target column, in target columns, right? LR model is equals to linear regression. Then, now what we want to do is use our scalar to scale the data before
Hello, guys. Are you guys still there?
X-train scaled form. X-train fits the LR model, so we just call the fits. But remember, Y-train has all these columns. Now we want only Y-train that is associated with this target column. So Y-train.
My screen is frozen. I can't see anything.
Oh.
Wait, it's updating now.
You can see it now?
Yes, I can.
Now?
Yes, it is better now. Yeah, it's better now.
Cool. Cool. So I repeat all this process, or you
No need,
Okay,
no need, no need, yeah, no need.
Okay. For target column, in target columns, fits instantiate a linear regression model, scale the data, fits the X train, and only fit it to the target column, which you have here for target column, target columns. Then after you fit, now you save the fitted model to LR models, the dictionary with the key, which is target call, is equals to now this fitted LR model. Cool. Now this will iterate over all these target columns. It will iterate in this list, take each target column, fit a linear regression model, save the fitted linear regression model in a dictionary with the key as the target column. Now, after all models have been fitted, you validate your models. Yeah, so validating is seeing how well your models are performing to unseen data. So same process. You can do this in this. Could you? No. Okay. Select the LR model from the dictionary with the key as the target column. Now use this on the scaled data, valid data. Now xvalid or xvalid after target columns. Scale up. Now after scaling, now you predict. So ypred call is equals to LR model, the one from the dictionary, predicts xval scaled. Now ypred, the empty list we instantiated above, ypred dot append the ypred call. Now it will have the predictions for each target. Now scoring. So the first time what I was doing, I was scoring for each column independently, but the method Zindi is using is not that. What they are doing is, which is the correct way. So first change this ypred list to an MP array. Let's see if it's okay. This scoring can do it in a new cells. Nice. Now we can see how ypred looks. Cool. Now we have to change this into an MP array and transpose it. So np.array ypred. Now yeah, that's the what I wanted. Now okay, you can score it in very many ways, but I'll show you what method I'm using, which is similar to the leaderboard method Zindi is using. So create for YPRED, data frame with YPRED and what the real actual value. Cool. Now we have our validation score. An RMSE of 2.24. 2.24. Not too good, right? So, but let's create that as our baseline. So we're going to try to beat this score, and to beat this score is actually too easy. But okay, should we try to beat this score, or should we try to make our first submission first? Which is better? What do you guys think? Should we try to beat this score in our validation, or we make our first submission first to create a, good. We create our first submission, cool. So it's simple. Now what you did to up here, just remove the scoring and replace this training set. Training sets, this training set spans from January last year to March this year. The training set we have used for validation. No, the training set we have used for validation spans from January last year to Feb this year, because we are using our validation set as March. But our original training sets was from January to March. So that's the only difference to this above code. So you just copy paste all this. Then change training sets. Okay, delete that part. To train, and validation sets to test. Only that. Yeah. Then fits, blah, blah, blah. Cool. Then this, what we did here, do it inside this code. And that's it. Now you'll have your predicted YPRED. Cool. So you want to transform these predictions to a submission file, and you can see how a submission file looks like. It has a prefix of April, headline, CPI, all the underscores have been stripped. So we're going to create a function for that, for which you can easily, what you'll just change is the prefix for all other nowcasting challenges. So prepare sub text in YPRED. It is a numpy array, target calls, which is a list. Okay. Tests, the test, which is a data frame. Okay. What else? It takes in a prefix. The prefix April, May, whatever challenge you're now casting. Then it returns a pd.data frame. Then you create a submission df using the pred. So how are you going to do this? Okay. Submission df is equals to pd.data frame ypred columns is equals to the targets, all these target columns which don't have the prefix. This now our data frame will have the ypred columns, okay. Target columns, no target calls. Now, after doing that, we assign the month. Yeah. Then we set the index to the month. Then now we try to assign the prefix and remove the underscores in the column names. Yeah. The prefix which you passed up here. So prefix, that's me. Then add an underscore. Then all these values here in the submission files are lowercase, except headline CPI, which you have to deal with that separately. So change them to lowercase, then replace the underscores in the column names, these underscores. In the column names with an empty space. What else? Now, this API, okay, now we have to deal with that. Let's try. There's one step we have not done, which is melting, which we'll do, but let's. Okay, I don't know the D type which you're supposed to specify here. We are going to deal with that later. Now it takes in ypred, target columns, test data frame, prefix April. Yeah. Now we have to melt it and deal with this. Headline CPI. Yeah. This CPI should be uppercase. So submission. Okay, there might be a better way to do all this. I feel like I'm repeating myself a lot, but Yeah, if you get a better way to do this, please update the code. So submission.rename columns is equals to, we want to rename only the CPI data for April. And since this we're trying to make it scalable to other months, now we cannot just write here April headline CPI, because for May now you have to change again to May headline CPI, which is too tiresome. So, but there might be a better way to do this. So if you find a better way to do this, update the code. We want to change it to prefix headline CPI. Nice. What else is remaining to close? Columns is equals to, okay, this is supposed to be a dictionary. Yeah. That's okay. Now we have to melt the data frame. Okay, this is in wide format. Now you have to convert it to these long formats, like the one we had before we pivoted in the beginning. So I'll post a better, I commented code in my GitHub later. So pd.melt submission df.reset index id vars is equals to month. What else? var name is equals to id. Value name is equals to value. Now submission df. Okay, let's try it out. Cool. So you just need to get rid of this month. This month right here. Yeah, it's a bit. There's a better. I bet there's a better way to do this. So you guys. No, I have to reset the index. I bet. So no, what you can do is just return the ID. Sorry guys. And the value. Nice. Now you have a similar submission DF like the ones Zindi provides. So let me charge my laptop in a minute. Any questions? It should be lowercase np array. Oh, okay. Thanks. np.array. I hope it does. Cool. Thanks, man. Cool. Any questions? Any questions before we submit our first submission to Zindi? The CPI rename did not change. Oh yeah. Submission df.rename prefix headline April headline CPI to why did it not change? It's supposed to have changed. So F prefix. Can you see the bug? Oh yeah. We renamed it, but we did not assign it to a data frame. So I bet that will change it. Cool. That's better. Thanks, man. Any other question? Any other? Did everyone code with me, or because I think I was too slow? Or let's submit. Cool. All you need to you assign it to a var, then submission dot to CSV April baseline index is equals to false. Now we have the baseline right here. Have we downloaded it? Have to download it, then okay. But we have 5 submissions, so next we are trying to be that one. So is it that? Yeah. Cool. 1.45. Let's see where will where will we be with that? 1.45. The private score. The private score was 1.4590. 1.4590. 1.4590. Number 43, 44. We could be in number 44 with that. Just simple lagging. Simple lagging. So any other question before we try to beat that score? Now we have the whole pipeline. It will be very easy to do other experiments. So any other questions before we try to beat that? Cool. Let me show you what's going on during training. I bet that is the okay. No one has asked, but I think that will be a problem to some people. So let's print all the target columns, and each time during validation, training and validation. No, it's not. Nice. So F-string training. And you do the same for validation. Cool. Now you can see it's training each column separately. So training alcoholic, etc., and validating each column separately. So if you tried to just train without saving your models in a dictionary, then you try to validate, it will use the last fitted linear regression model on this last category, transport, to predict for alcoholic beverages, which you don't want. That's why we are saving them in a dictionary for each target column. So next thing you're going to do is try to beat our score. And yeah, no questions. The only thing you're going to change, actually this is the fun part. So the only thing you're going to change is the range of lagging, because these are the features we are using. These are target columns. Then let's add something here. pd.options.display.max columns. You can only set, is it dot columns, max columns, max columns. You can only set the value of existing. Oh, yeah, max columns. Nice. So the only thing we're going to change is this, the range. So currently we only have previous 1 month value of each target column. So let's add to 5. So 4 months. So arrange 1, 2, 3, 4. Cool. And we run this. So we don't need this. So, but the simple way is, okay, do you guys want to know this simple approach of just adding the difference of last year gets you to which position? It gets you to top, if it's not top 20, because I had it somewhere here. Okay. It gets you to 0.57, just adding the differences. It gets you to 0.57. But now that you can't add any more features, so that's the problem. So now we have changed the range. We rerun the whole of this code. But first, let's see what's going on here. So we have previous 1 month, previous 2 months values, previous 3 months values, previous 4 months, previous. So up to 4 months for each categorical column. Same thing. Cool. Remember this RMSE 2.24, right? This is what we are trying to beat. So now we are at 1.01, just changing the range, man. 1.01. That's a difference of, but since this data is not, it's only rows after pivoting, after 14 rows. So there's a lot of randomness. So you have to find a stable validation, which is going to be a problem as like the challenges get on. But you have to find a stable validation. Now, when you see a difference in validation score, go and try to submit that submission. So now it's not a baseline anymore, it's sub 2. And you see if the decrease in validation score translates to the decrease in leaderboard. Now with that logic already explained, with that correlation, LB validation correlation, now you can trust your validation, but you have to find a stable validation scheme first. That's the goal of any Zindi challenge or Kaggle or any other challenge. So sub 2. And just like that, we are 0.99. 0.99 gets us to 0.99. Gets us up to position 37. Position 37. We have not done anything much. So now if we try to add more things, Okay. Now let's bring vehicle sales to the picture. Now vehicles are so the goal is to find a sweet spot in the lags. So as the lags increase, now 7. See, as you increase the lags, you get better and better schools. But if you do it too much, it gets worse. So let's say 9, it gets worse. So the goal is to find a good cross-validation scheme and a sweet spot for your lags. If you exhaust all these options, now you try to go and add additional data. And adding additional data, so it gets better, 0.83, 816, and you can try to submit that. But don't do it too much. Like there's a point where the scores get really worse. So find a sweet spot. Now validate your models. See which one has a very low score. Then submit that to Zindi. Now this has 0.773. Let's try to submit. But now we have how many submissions left? Okay, I'll just show you how to add vehicle sales. Then you guys can add more additional data that has been provided to the links and see if it's improve your score. But since you already have the values for April from the May data, we can use that as our local validation. So if time allows, I'll also show you guys. And you should post your questions here. Like ask me questions, man. Ask me questions. Sub3. How does Sub3 perform? Sub3. Now we are at 0.6349, man. 6349. 6349. That's 25. I mean, number 24. Cool. So that's it. Just play the lags. Now I'll show you how to add additional data. Cool. Vehicles. And you guys don't, if you have never, like, if they are beginners here, there's a certain adrenaline rush that comes from improving your score that makes you not to stop, that makes you to fight, man. So make your first submission on Zindi and have fun, Mazi. Have fun, man. Now we have to add vehicle sales. Let's see if this now improves our score even better, even more. That's even better, even more. If you can get to top 20. And remember, all this has not beaten the simple model, the one for adding differences that happened last year to the current. So you can use the differences as a feature to this model. Additional to the lags, use previous year's change between months difference as an additional feature, and you'll see if it improves your model or not. That's the basic point of machine learning and challenges. Try everything that improves your score. Try everything, Mazi. So, vehicles. Now we add vehicles to the picture. Now, same idea. Now let's remove this. vehicles. .head. Okay, this will be handled a little bit different because, as you'll see, the dates have not been passed so well. So you have to pass the dates in the right format. And the starter notebook Zindi provided had the method of how to do that. So I'll just copy paste that, or I'll just do it from scratch. So now you have months, export sales, which has a lot of data, but you're only going to focus on the total columns, total local sales, total export sales, the total columns only. But you can experiment with other columns. Now, since you can see this 23 March does not resemble this month column for the CPI pivot, so you have to deal with that. So I'll add a new section here just before feature engineering. That adds vehicle sales. That adds vehicle sale. I mean additional data sources. Additional data sources. Now you have vehicles. Now we need to pass the vehicles. And should we go to the starter notebook and just copy paste, or should we do it from scratch? But before, any other questions? So you mean adding more lags may increase your performance, but too much of it can lead to overfitting, hence need to collect more data. Yeah. So if you have more data, if you get a free source that is of free CPI historic data for South Africa that spans across multiple years, because now we have only 2022 data and 2023 data, which is 14 rows. 14 rows is not a lot for your ML model to learn. So if you want to use models like XGBoost, like GBM, CatBoost, you need additional data sources. Even linear regression can benefit from more additional data. So if you get a free source which has multiple CPI historical values of 2021, 2020, etc. I don't think if there is, then that's a game changer. So you just make sure it's a free source, and you talk to Zindi if they are cool with it. And now you even doing that, you need to find the sweet spot for your lags. When dealing with ARIMA models, there's a way they find lags. I don't know what is it called. I've seen Bwenge. Here. Bwenge, can you tell us how ARIMA models find the sweet spot for lags? So I've not worked with ARIMA models. That's why I'm teaching you the approach I used to get to number 5 on April's data, which is just a simple linear regression with lags. That's it. That's the method I'm using. But other guys are using time series forecasting methods like ARIMA, even exponential smoothing if you do it well. So yeah, you should research. And there's this GitHub repo. I'll show you guys. It's a really cool library. I mean, example of using SRIMA. I'll just paste it on the platform. You can go check it out. It's using SRIMA for forecasting passenger sales, I guess. So finding the sweet spot for your lags, finding the best additional data is what will differentiate your model from being in the top 5, top 10, top 20. Because this can get you too far. If the lags stop working, what will you do? So also, so you can see there's no assembling here. There's no any fancy thing. It's just normal stuff that which is taking past historical values and improving your model using the lags. Only that. So yeah. Any other question before we continue to additional data sources?
Hello.
Oh, there's someone talking.
Yeah. Hey, Kolesh, I hope you are hearing me.
I cannot hear you so well. Yeah.
Problem with my mind. Maybe I can just ask it in the end of the class.
Okay. Uh, okay, while you type on the chat, yeah, please do type on the chat. As you type, let's continue the vehicles. So you mean adding more? Yeah, let's continue the vehicles. So you need a library for dates. Then you need to create. So here, the date itself is not that important, like the 31, 28, 31, because we are dealing with monthly values here. So we have to we can just create a new column called year month that takes in just the year and the month. Cool. Sorry, guys. Is there any more questions before we continue? Okay, no questions. You guys are not asking me questions. Why? Why are you not asking me questions? So now we SPI pivots year month is equals to, since it's already in, okay, pd dot to date time. CPI pivots month.
Hello.
Hello.
We are not seeing your screen.
Oh, okay. Sorry. Can you see it now?
Yeah.
Thanks for letting me know. So what I was doing here is I have to create a new column called year month, which takes in just the year and the month, which we'll use to like merge our additional data sources to the original data frame, the CPI pivots. We're doing this because the dates here doesn't matter that much. Plus, when you look for by the date, I mean the day, not the date, the day, the date itself. So, for example, this vehicle's data, we have been given it in year and month. So 23 means 2023 March. 2023 Feb means 2023 Feb. So you can see that here it's only the year, that the year and the month, which are really important. But if you can find a way to use the day, cool. So that's what I'm trying to do here. So now we have to convert the month to a format that takes in the year and the month. So how is it done? Format, I guess, is equals to percent. Is it percentage here? Yeah. Or you can just go to the. I think the starter notebook had that. Just copy paste. Starter notebook. Where had they implemented it? So in the starter notebook, they're using a statistical approach here. So you have to strip the month, use a date range. Oh, nice. Let's just do it our way. That's dt dot percentage month. Nice. Let's see if that works. Cool. Yeah, that is what I wanted. Now, since the vehicles is in 20, it's not like in this format. Now we have to have start date. It's here. This. Copy that. Paste it here. Then you have start dates. But now when you look at this is not, I don't think it's the right way to do this, because when you look at vehicles.tail, I mean
vehicles in itself, it started 20th deck and spans to 23 March. But here, yeah, 23 March. So I bet they used the month start. So we are going to use the month and 31. Was it 20th deck, 2020 deck? 2020 deck to 2023 March, January, February, March 31. And nice. Now we have to use this to get the range. So on the starter notebook they use month starts here, but as we are going to use month end, so that there's some errors I was getting, and I think this solved it. So a date list is equals to pd.date range starts dates end dates frequency is equals to, then yeah, I have the date list. Now we just have to pass the vehicles date column to this. So vehicles month is equals to date list. Yeah. Now you do the same thing that you have done here. Okay, let's just see how vehicles month look like. Vehicles month. Nice. Now we have the dates, but you don't need this. We want year and month. So you just copy paste this, but do it for vehicles. So vehicles, yeah. Now dot head. Now we have it in the right formats. Now data spans from 2020 DAC to 2023 March. Cool. Now we have to merge. You have to merge this data. But as I told you earlier, we are going to use, okay, based on my experiments, I found that using just the total local sales and total export sales is much better, and also not to clunk your data frame with a lot of columns. But you can do that in a free time, add additional data, columns. So what you want is to merge these vehicles. Okay, let's just do it. Is equals to pd dot merge CPI pivots. Then it merges vehicles, but not everything. So not that year month, which we'll use on to merge on. Then uses total local sales and total export sales. These two last. So total local sales and total export sales. Total export sales. Yeah. Since we already created a year month column on our original data set. We use that how every row in the left should have a value. Then how is equals to left. Now when you see how this looks like, there's no total export cells, so that's a typo. Total export underscore underscore underscore. Nice. Now we have additional data. Okay, I should have done this after I've restarted the notebook. So cool. Now we have total local sales, total export sales, which also don't have a value for April because we don't know. Now we lag even this. So for all features to lag, now it will include total local sales and total export sales. That's the beauty of writing scalable code. Now, when we do this, we'll also have lags for total export sales and export sales and total sales. Then now something will change here. Now target columns will no longer be features to lag because now features to lag has the additional columns. So total local sales and total export sales. So an easier way to do this, since this does not change, just create its own separate list. And nice. That's all you're trying to predict. So cool. Now, yes, cool. So, okay, this is a lot of verbose. Features for call. Oh, now we also added year-month as a column, so you have to get rid of that too. Yeah. Now features. Should we look at the features? Okay. Now training and validation. Now we see if the additional features improved our model. Could not convert string to floats. Oh. The lags also include year month. We should drop it. So year month features to lag. Damn. Features to lag. Now features to lag includes year month. So for call in features to lag. Okay, you can do this in a better way on your free time. But since I'm getting mentally tired, so if call not in because you don't want to lag that. Yeah. That should solve it. Cool. Trained and validated. Now to the validation, to the scoring. Now it's the score reduced from 0.77 to 0.74. So how does that translate to the leaderboard? Input X contains none. Linear regression, but we filled all the data, man. Oh, yeah. So remember we added features like which have nones. The total local sales, we have no value for April, and also total export sales, but we have not excluded those columns from our training features. So what you do for any additional data source which doesn't have a value for April, just don't train with it. Don't train with it. So, Where? Oh, here. So you just replace that's. And now it even reduced further from 0.77 to 0.71. How does that translate to the leaderboard? Yeah, no error. April sub 4. Cool. We are now at 0.5902. 5902. Where could we be? Number 16. Yeah, so you can see like gradual and CPI. Yeah. Sorry, I lost. Okay. Yeah, I'm trying to merge CPI pivot and vehicle data set, which I've done. So as you can see, gradual improvements in additional data sources and features leads to gradual improvements in the score. And for April, I'll be honest with you. So there are a lot of data sources. We have vehicles, we have index currencies. You should try them all. But the secret lies here. The secret lies here. To get the secret lies here. These parts, these additional links. This is the secret. To get this score 0.37, you want to get it with just the data sets. Maybe you can. I really don't know. But with me, with all my experiments I've done, I feel like all my improvements have been brought using these links. So you just want to find your secret source from these links. But do it after you have experimented with all the data sets Zindi has provided you with. So now today we're going to do like a simple baseline of one lag previous month only. We saw how the score is decreasing in the validation and also on the leaderboard. We saw how to improve using more lags, but find your sweet spot. And we saw how to use additional data sources to improve your score. So now we started with 2.3. Okay, we started with 1.45, and now we are at 0.59, just using the data set Zindi provided. Now, imagine if you add all this data, you find how to use this additional data. Plus, now we haven't even used currencies and indices. Plus, you add this data in a creative way. Plus, you also add the difference data, which I've shown you, using the seasonality trends. You'll build a really powerful model. So, just experiment. Okay, other guys might be very successful with that SRMA. I'm not familiar with SRMA, to be honest, so I won't speak about that. But if someone was successful with SRMA, please share it with us. If you got a better score than a top 20 score using SRMA, we should. And I also shared a link of this link here. ARIMA has a cool example using SRMA. So yeah, any questions? Please ask questions.
Hello. I was saying I got lost a bit. I found out that you merged some data sets. That's the CPI, the CPI pivot and the vehicles. So I'm wondering, if in the vehicles, did you merge all the data sets in the vehicles data set, or you just pick some columns in the vehicles data sets?
So this is a matter of preference. So you can add all the columns, but for me, the columns that worked for me is total locals, the total columns, the total local sales and total export sales. But that's for me. So for you, you have to experiment with all others because our minds don't think the same. So you might find success using other columns, which might be your edge to getting very good scores. So it's a matter of experimentation. Try, validate it. And now, validation is so simple. You don't need to use much now. So now, April's data was released months ago. So now use that as your validation, as your local validation if you are now casting for May. Use May's validation if you're now casting for June. And now for July, use June's validation when they release it if you're now casting for July. But this approach, I forgot to tell you, only works after the real CPI historic values have been released. That's the disadvantage of this. So you have like most of the time they release it on 24th of each month. So you have like 6 days to play with this approach. 6 times 5, that is submissions. That is submissions. You need to have a stable local validation to be able to create a very powerful model. So yeah. Could you explain a bit that? Okay, Kefa.
Okay, apart from that, I have a general question that's away from this scope of this class.
Yeah.
So I was wondering about the feature importance.
Yeah.
In trying to use feature importance, I don't know basically what feature importance means, but to my understanding, I thought that the feature importance, it gives you the importance of each features, like it ranks the importance of the features from the most important, like which feature has an influence to the target variable. So it will rank you from the best one to the last one. So I tried in some project to remove those features which are of less importance. So, but to my surprise, I don't know. I was using the metric, I was using the MSE, but in the MSE, I found out that it had a lower performance. But I had removed
after removing the features with low importance.
After removing those features.
Were you removing the features with zero importance or with floats 0.0 something?
Yes, I was removing those feature importance with those features which had the importance nearly next to 0.
Oh. Yeah. So these okay, I don't have the actual accurate answer for this, but I had certain competitor on Kaggle saying sometimes the features you remove which have 0 values, when you try to use them in interactions with other features, they might be important. So dropping them not necessarily means your model will improve, but I'm not sure. So to be honest, I'm not sure. I'm not sure why your model why dropping will decrease our score. But this assumption that we should not remove the features with zero values, because when they are used in interactions with other features, they tend to add some importance to other features. Which, if anyone has a clear answer to him, please.
Hello guys.
Please. Hello guys.
Hello guys. Yeah, I would like to try to say something about the question he raised. In fact, me too in a certain challenge, I tried it and it worked. But also in another challenge, after training the model, I got the feature which contributed to the to the training of the model. The most relevant feature. So I tried to after I reduced them according to their importance, and after retraining the model with the reduced feature, it worked. Then for another competition, I tried the same thing but didn't work. And then I concluded that that is not like a straightforward approach. It can work for, it depends on the data set. It depends on the data set. Of course, as Kolesh has said, sometimes features that you have removed combined with other features may have helped the model to learn, but when you remove them, then it can perform badly. So I think that case, it depends on the problem. It depends on the problem, majorly the data set you have.
Nice, thank you, Buengi. Thank you, Buengi. I hope Kefa you have heard. So it's not a straightforward thing. Yeah, so thanks, Buengi. Kefa, is that all?
Yeah, thank you for that.
Thank you. Also, thank you. Can you explain a bit the flatten method used in the previous code? The flatten method was a safekeeping way of ensuring that both the y pred and y value have the same dimensions, because these are parts where, okay, here when we look at y pred, it has multiple dimensions. So flattening it will get rid of the now you have just one dimension. That's the only, it's a safekeeping. So for example, y-val and y-pred don't have the same dimensions. You convert them to a similar dimension. Yeah. Cool. Any other question? Will the video be shared later? So I'm really sorry, guys.
Okay. I think I can add something about the flattening.
Yeah.
Yeah. I saw something in the planning that when you are flattening, like in a when you are given a matrix.
Yeah.
Let's say a 3x3 matrix. So when you use a flattening, it will like make that matrix into one column.
Nice.
So I don't know if this applies to this one also, but I guess it's the same.
Yeah. So when you looked at the y pred, it had two dimensions. So when you flatten it, both you just make sure they all have one dimension. So like it's a MP array, just an MP array. Yeah. So my network was so unstable during the session, so I don't think there's a place here to to save the recording. But will it be continuous, or will it start after my network came back? So I've never used Zoom so well, so I really don't know. So who has used Zoom? Will this session be full, or will it start after my network came back? I really am not sure, but yeah, if it will be a full video, it will be shared later. So I hope you guys had fun. I hope some of you coded with me. So for example, for July, when they release the data set for, the CPI historic values for July, what changes is these vehicles, you should replace it with data for June, for the data they'll provide during that July period. Also, this should be replaced with the CPI values provided during that July period. Also, this row should be now July. July has 31. So you just replace this with 731. Yeah. And as you add more additional data sources, remember to remove them in the training features, because now if you add additional data sources whose values are not known during that month, then it will decrease your score, plus it will not be able to predict using a LR model or any linear model. So what else changes? This change, validation changes. Now for July, you'll have 731, 731. For training and validation set, you'll have 631, 631, because now you'll use June as your validation. Then what else changes? This prefix changes to now July. That's it. That's everything you need to like change. Also, here you can add subsections like vehicles, and every time you add an additional data source, make sure you merge it to the original data source. To the original CPI data. So you can add, currencies, indices, and all the links provided in the platform. As long as it's freely available, you can use it. Nothing else changes. Login, find your sweet spot, add more features, add different features. And also you can play with this dropping. You can drop the first 2, 3, maybe to improve your score, make it stable. But this is not a winning, it's not a guarantee winning solutions. Explore SRM. I'm also learning about times. There's this YouTube channel, Abhishek Thakur. Just search Abhishek Thakur. Then there's a whole playlist dedicated for time series. This time series with Conrad, it's amazing. Talks about ARIMA, prophets, transfer learning for time series, validation methods for time series, hybrid. It's amazing. Use that. Also, the link I provided for this repo, ARIMA, Kaggle. There's a lot of resources in Kaggle. Kaggle time series. Just search Kaggle time series forecasting. And you will see intro to time series forecasting. There's a lot. And this might, because for me, I've really tried to beat this guy, even after the competition has ended. This guy, 0.37, is amazing. I don't know how he did it, but the approach he's using is really good. Really good. So I really don't know what other guys are using. So for me, I'm using just an ML approach, but I'm also learning about other time series forecasting. The only approach I've not used is the statistical, which might also be a game changer. So just compare multiple approaches. That's all I'm going to say. So if you don't have any other question, I have a question for you guys. How did you find this session? Do you want more of these sessions? And if you want more of these sessions, which current competition can we do? Because I've done this, and I've done this. Yeah. I can create a session with this, a simple baseline. ChatGPT ML challenge, I've not tried it. Okay, I'm so poor at image satellite imagery competitions. I think I have to partner with someone who is good in satellite imagery, who can take us through of how to create a fast baseline. So these 2 competitions. Then this is good. We can do this. I wished to do this, but it's ending 7 days. So the goals of this session is to create an early baseline approach for all competitions, because I don't want to hold these sessions when the competitions are ending and now everybody will be clanking the leaderboard with the same score. No, I want it so that's to give everyone time to do more research and to improve the model. So I need you guys to Yeah, same. I actually had a hard time trying to understand the starter notebook. For real, they're using a statistical approach, which, to be honest, I'm not so good at. So maybe it's also what this guy is using. The first guy, don't ignore any approach. Like, just learn. Learning isn't easy, but it's worth it. It's worth it. So, question: how did you find the session, and which competition do you want us to go next? It's in 2 weeks. We're going to have these sessions 2 weeks. And what do you need me to improve? I'll definitely improve on my Wi-Fi. I'm so sorry, guys. So please type on the chat. Let me know, how did you find the session, and which competitions do you want me to go next? What do I need to improve? etc.
Hello.
Hello, Bwenge.
Yeah, first of all, I would like to thank you for your time and everything you have helped us to go through.
Yes, thanks.
Yeah, we really appreciate it. Thank you so much.
Thank you, Bwenge.
Yeah, but also I would like to just mention something that I heard you, like, I wanted just to emphasize a little bit on it.
Yes.
Something that I heard you were trying to explain. And
yes.
It's all about competitions or problems in machine learning. Okay, according to some experts out there, but also for what I've understood, it's like machine learning is not a straightforward problem. You know,
True.
Problems like with other sciences like chemistry, physics, and others, you will be knowing, if I'm to do this, I'm going to get this. If I'm to do this, I'm going to get this. But
yeah, true.
Machine learning is all about try and error. So
true.
We are like more like cookers, chef. They call them chef. Yeah. Okay. Sorry for my English. I'm from a French background. We are like
no
chef
worries.
we are like chef than like chemist, something like that. So as Kolesh has been saying, is just a matter of trying everything, and what works for you, you keep it, and if there is a possibility, you share it with others. Thank you so much for your time again, once again.
Thank you, but you have not told me which competition you want us to go next.
Yeah. By the way, yeah. In fact, I'm kind of new to all about deep learning. Yeah. So I wanted, like, if possible, we can go to the other one with satellite images. I think it could be okay, like if we are to have a base model with that, or if we are to have like a base approach, it could be okay.
Nice. Okay, so for satellite imagery, I'll invite someone else to talk about it, because I'm not good at it and I also want to learn. So that's for sure. We are going to organize about that. Okay. I could not understand the starter notebook lacuna. We could go to that next before we.
Yeah. Which is also good.
Yeah, and there's that for predictive insights, which is also good, even though it's only for South Africans, but it's open for all, so we can learn. We can learn too.
Yeah, but also I would like to thank you once again for for this kind of initiatives. I don't know who started them, but it was very, very nice. But also I came to learn about this mostly. Okay, like on Zindi, I could just be around, and then I saw some kind of links whereby they were calling people for this session. But also I saw it on my mailbox, and I said, oh wow, this is interesting. I think participating it could be okay. And then I tried also to share with people.
Nice. Yeah, we'll be having this frequently. I'll be letting you know in advance. And I'm so glad everyone joined. So I've only gotten opinion from Bwenge on which competitions they want us to go to next. Also, Kefa, we should try predictive insights youth income prediction too. We are going to organize which comes first. For Kolesh, 5 stars. Oh, thank you. 5 stars for Kolesh. Thank you so much. But to be honest, I'm also like you guys. I'm also learning. And let me tell you my story in a very short brief. I started data science as a newbie. Like, completely new to it, so I've learned through competitions. All the competitions I've learned, I wish like the discussions could be more like Kaggle, you know, like people are posting like helpful links, helpful solutions, but people here are so kept to themselves. That is what I'm trying to change. This is the initiative I like wanted to bring to Zindi. Like, don't keep it to yourself. Teach others. Others may have very creative ideas, but they don't know how and when to start. Just show them the direction. After showing them the direction, leave it up to them. Let them learn, let them come with creative ideas. That is what I want, like a good community, active in the discussions, helping other guys, etc. And I hope we make it. So for example, I'm not good at satellite imagery because in the past 3 years I've competed on Zindi, satellite imagery have become common. Like, okay, maybe I was not like so active in satellite imagery competitions, but they have become very common this past year and this year. So there are guys here. I think Adeyinka Sotunde is Mikadi. Mikadi has handled satellite imagery competition. Maybe we can invite him someday in this session to guide us through making our first baseline and help us. That is the goal, man. Like to help other guys, helping other guys. And it doesn't have to be me always. No, like I'm just an intermediate. Other guys like Mikadi, Tommy for real, like other big wigs in Zindi, Assassin is so good in deep learning. Like we should make this an initiative of all the community. Like we come together, we learn, and that's how we grow. That is the goal of these sessions, and I hope we make it. So, yeah. If we don't know something, we invite a better guy who has handled it before to guide us to it. Thank you so much. Yeah, this is Mikadi. True, I knew. Adeyinka Sotunde is your username from Git, and I follow you. So I must say you're doing a great, well done. I believe we all need to keep this going like this. Teaching other is the greatest way to know more and more. I threw myself out to anyone that I can learn from the beginning when I first joined. True, man. True. It will be really helpful since you've handled satellite imagery before, because guys have suggested we go through like Geo AI challenge. There are 3 months to go. It doesn't have to be this month. Maybe when the 2 months remain, you can just join us and guide us through. But it's an honor for you to join us. Thank you so much. And for everyone who has joined today, you suck. I know you, man. You won the Zindi User Engagement Challenge. Great job, man. Great job. And everyone else, let me see the Buenge is a good friend of mine. Emmanuel, nice to know you. Nice for joining. Kenny Martin, thanks for coming. Emmanuel Slodako, thanks for coming. Abdullahi Bangura. I'm sorry if I'm pronouncing your name so wrong, but
That's
sorry. Right. But I'm so grateful for all of you for joining. Mlulekim Tande, thanks guys. And I need your opinion, guys. Let's vote for the next project we hold live sessions for. So please guys. So Buenge has chosen. Okay, just everyone to type 1. I'll choose from the top performing. Top performing choices will have the next session in 2 weeks. So guys, type. Thanks, Emmanuel. Type the next competitions you want. These are the competitions that are currently active. Lacuna, Geo AI Challenge, both of them. They might be advanced, but okay. Predictive Insights, cool. Yeah, those are the active ones that are remaining now. So Abdullahi, satellite image competition, okay. Kefa, please type the next. Oh, Kefa said predictive insights. Yeah, nice. Isaac Birham, please. You should tell us which competition you want to see next. Lacuna, great. Lacuna, Mluleki, please type. Kenny Martin, please type. Emmanuel Sladako, please type. Lacuna, great. Lacuna, great. Okay, Lacuna is winning. Great. Next session, Lacuna. Lacuna. We're going to create a simple baseline for Lacuna, then go through past approaches that have worked. Yeah, great, Kenny Martin. We'll try it. Then we can like go through it, create a baseline. Thanks, guys, for joining. Thank you so much. Thank you. See you when I see you.
Okay, thank you very much.
Thank you, man.